Good afternoon to everyone present viewing us. We're group number 5, made out of Ángel, Malena, Mauricio, López, César, Feliz, Zaida, Lajara, and myself, Isabella, Molina, senior year. Today, we have the pleasure to present to you in this video, trigonometry. In this video, we're going in detail, explaining concept and theory of trigonometry, as well as explaining the 6 trigonometric functions. They are explained in the presentation as well. Later on, my peers Zaida and Mauricio will bring some examples of eco-friendly structures that clearly involve trigonometry in them. Finally, César will be presenting some real-life examples of trigonometry and how to solve them. And as just mentioned earlier, trigonometry is one of the most important branches in the history of mathematics, and this concept is given by a great mathematician, Hipparchus. Here, we will study the relationship between the sides and angles of a right-angled triangle. The basics of trigonometry define 3 primary functions, which are sine, cosine, and tangent. This is one of those divisions in mathematics that helps in finding the angles and missing sides of a triangle with the help of trigonometric ratios. The angles are either measured in radians or degrees. The commonly used trigonometric angles are 0, 30, 45, 60, and 90. The prime application of trigonometry in past cultures, not just ancient Greek, is to astronomy. Computation of angles in the celestial sphere require a different kind of geometry and trigonometry than that in the plane. The geometry of the sphere was called spherics and formed one part of the quadrivium of study. Various authors, including Euclid, wrote books on spherics. When we learn about trigonometric formulas, we consider it from right-angled triangles only. In a right-angled triangle, we have 3 sides mainly: hypotenuse, opposite side that is perpendicular, and adjacent side that is the height. The longest side is known as the hypotenuse. The side opposite to the angle is perpendicular, and the side where both hypotenuse and opposite sides rest is the adjacent side. Here we can see a list of formulas for trigonometry, where it says basic formulas, reciprocal identities, trigonometry tables, periodic identities, cofunction identities, and so much more.
In this section, we are going to explain the six trigonometric functions and their formulas. But first of all, what is SOHCAHTOA? It's a mnemonic device to help you remember the 3 basic trigonometric ratios used to solve for missing sides and angle in a right triangle. There are 6 functions of an angle commonly used in trigonometry. The mains are sine, cosine, and tangent, while the others are cotangent, secant, and cosecant, that will be mentioned later. This trigonometric function describes the relation between the angle and the side of a right triangle. In here, I'm going to explain the main function of a right triangle. First, we have the sine function formula, that is, angle of right triangle equals to opposite side over hypotenuse. This function establishes the relationship between the opposite side of the triangle and the hypotenuse. This can help us to find the adjacent side of a right triangle. The second one is the cosine function formula, that is, angle of right triangle equals adjacent side over hypotenuse. This function establishes the relationship between the adjacent side of the triangle and the hypotenuse. This can help us to find the opposite side of a right triangle. The third one is tangent function formula, that is, angle of right triangle equals to opposite side over adjacent side. This function establishes the relationship between the opposite side of the triangle and the adjacent side. This can help us to find the hypotenuse of a right triangle. Then we have the reciprocal function. First, we have the cosecant function. This function is the reciprocal of sine. The formula is angle of right triangle equals to hypotenuse over opposite side of the triangle. The second one is secant function. This one is the reciprocal of cosine, and the formula is angle of right triangle equals to hypotenuse over adjacent side. Then we have the cotangent function. This function is the reciprocal of tangent, and the formula is angle of right triangle equals to adjacent side over opposite side. These 3 reciprocal functions can be helpful in solving trigonometric equations and simplifying trigonometric identities.
Now I'm going to explain 2 exercises involving trigonometry in real-world problems. Okay, the first step is identify what is the exercise asking me to find. In this case, the exercise is asking me to find the height of that tree. So the value that we have to find is this one, located in the opposite side. Then we have to identify the information that the exercise is giving me. Here we have the shadow that casts the tree, which is located in the adjacent side. And its measure is 39.3. And we have the angle of elevation that has a measure of 42 degrees. Okay. So the next step is we have to choose one of the three main trigonometric functions. And the trigonometric functions and that we choose have to deal with the side that we are looking for and with the side that the exercise gave me at the beginning. In this case, the trigonometric function that I have to use is tangent. So why tangent? Tangent is the better one because it uses the both sides that I'm using in the exercise. So now we have to write the formula of tangent, which is tangent of an angle is equal to opposite side over adjacent side. Okay, now we have to add the values to the formula, and tangent of 42 degrees is equal to x because we don't know that value, and 39.3, which is the value of the adjacent side. Okay, after it, we have to leave alone x crossing multiplying the 39.3 to the other side. So go ahead, 39.3 multiplying by tangent of 42 degrees is equal to x. Okay, now we have to know the value of the tangent. So 39.3, and tangent of 42 has value of 0.90. So 0.90 is equal to x. And the final step is just do the multiplication. So 39.3 multiplied by 0.90 is equal to 35.38. So that's the final value of the x. In other words, that's the value of the opposite side, which is the measure of the height of the tree. Okay, now I'm going to explain another exercise more that is based in a building of 60 feet of height that is being watched for an observer who measured an angle of elevation of 40 degrees. That's the measure of the building, and he wants to know how far is he from the building. So that represents the adjacent side of the right triangle. Okay, first we have to do a representation of the problem. We have that already. So now we have to choose again one of the main trigonometric functions. In this case, tangent. And why tangent? Tangent is the better one because it uses the opposite side and the adjacent side. So we copy the formula, which is tangent of an angle is equal to opposite side over adjacent side. Okay, now we have to put the information of the exercise. So tangent of 40 degrees is equal to 60 over x, because we don't know the value of the adjacent side. So now we have to leave alone the x in one side of the equation. So the next step is change positions of the tangent with the x. Now we have to put x is equal to 60 over tangent of 40. Okay, so now we have to know exact value of the tangent of 40, which is 0.83 in this case. 0.83. So now the final step is just do the division, and the final value will be 71.5. So that's the final result of the adjacent side. In other words, 71.5 feet is the distance of the observer from the building.
The last part of the presentation is green building, example of trigonometry in eco-friendly sculptures. A green building is a building that in its design, construction, or operation reduce or eliminate negative impacts and can create positive impacts on our climate and natural environment. Green buildings preserve precious natural resources and improve our quality of life. One example of green building is the Pisa building, was created in 2010 and is an example of sustainable construction located in the urban area of Melbourne, Australia. It is the first office building in that country with zero carbon dioxide emissions and is capable of generating its own energy and water. It was created by the Studio 505 Architecture Office, and it received a perfect rating of 105 of its green building, awarded by the US LEED system for sustainability of the project in the management resource utilization with one of the most advanced water. The highlight of this project is energy efficient, renewable energies, water collection system, waste reduction, and green roof. The colored panels that are covering the sculpture are accompanied by double glazing that allows an excellent management of light and shade inside. In addition to providing natural ventilation, minimizing the need of energy. The construction has an inside in addition to colorful, innovative, capable of reaching carbon neutrality, including climate toilet system, fixed buildings with sharing device, and a few car parking spaces to promote other forms of transportation. It also includes a roof with gardens that collect rainwater and allows the harvest. The energy that the building generates is through solar panels and sharp wind turbines vertically installed on the ceiling. The project initially emerged as an office prototype future and is currently evaluated by the environmental authorities to determine its sustainable capacity.
Green environmental savings. The world over, evidence is growing that green buildings bring multiple benefits. Green buildings offer one of the most important types of benefits to our climate and natural environment. They use less water, energy, natural resources, and they generate their own energy. At a global level, the building sector has the largest potential for significantly reduced greenhouse gas emissions compared to other major emitting sectors. This emission savings potential is said to be as much as 84 gigatons of CO2 by 2050 through direct measures in buildings such as energy efficiency, fuel switching, and the use of renewable energy. Another example of a green building is the Taipei 101. This building was officially classified as the world's tallest from its opening in 2004 until 2010 by the convention of Khalifa in Dubai. Taipei 101 has a height of 508 meters and has been awarded by the LEED Platinum Certification for Energy Efficiency and Environmental Design. Taipei 101 energy consumption is 30% lower in comparison to an average A building, leading to annual energy cost savings of $700,000.
In conclusion, we can say trigonometry helps us to calculate distance without the need to travel, and they were fulfilled by means of circumference triangles and others. Trigonometry in real life is widely used since we can measure height or distance, measure angles, among other things.